The lecture is sponsored by the Middendorf Foundation, and the foundation has generously provided support for both a George C. Graham professorship and lecture, as well as the nutrition programs in the school, and we're very grateful for that. And we have some guests I want to recognize and welcome. Alec Graham is here, George Graham's son. Thank you for being here and welcome. Laura Holter with the Middendorf Foundation, I think, is here. And Laura, thank you for being here as well. And then Linda McCleary, also with the Middendorf Foundation. So thanks for being here with us. Yesterday, this has been a great week for the school. You know, we've had 3 big events. We had the Baker Portrait, and yesterday we had the Gutermode Award. And it was really our good luck that Andrew Prentice could be here yesterday, and I got to interact with him, and he was at the ceremony, and we had dinner last night. And so just from that brief interaction, I know that we're in for a treat today. And he shared several highlights, several insights with me, and I think Keith is going to do a detailed introduction, but I'll just say that as we talked about with our award winner yesterday about the challenges of working in the Congo, Andrew indicated to me that he was born and bred in Uganda, and he's an African and feels passionately about the issues in Africa. And he's going to talk to us about that today, about designing and conducting trials there. And you know, I'm especially looking forward to, because I know that you look at plausible biological mechanisms and then take that and move it to the field, and not easy to do. He's been a longtime friend of our school, of Keith and the people in the nutrition center. So we're really happy that you were here yesterday, and that we got time to spend time together last night, and then we're looking forward to your talk. But my job is really to introduce Keith West, who probably everybody in the room knows. Keith is the director of our Center for Human Nutrition. He is a registered dietitian who was in the Army and got sent to Bangladesh during the famine, and it transformed his life, and he sought education in public health and has been here ever since, and is an international leader in micronutrient trials and supplement trials, especially in the developing world. So Keith, please. And he's the Graham Professor. I should have mentioned that.
Thank you, Dean Clagg, and thank you all for coming here today. This is truly a very special event on our academic calendar here at the School of Public Health, to have a lectureship that is in the name of George G. Graham. George was the founder of the then Division of Human Nutrition in the 60s. And the founder of the Institute of Nutrition in Lima, Peru, also in the 60s and 70s. He was a pediatrician, he was a scientist, he was a nutritionist, he was a mentor. He knew something about just about everything. And what he didn't know, the little bit, he certainly had an opinion about it. And he was a thinker. He was independent in his ways. He looked at data and interpreted data. And if the data didn't say something that he didn't see, he didn't say it. He never backed down to dogma. He always allowed his scientific principles to stand and to interpret. And he used those to interpret his area of science, pediatrics and nutrition. He was awarded numerous awards. He was an international figure of tremendous standing, and really one of our tall trees in the Hopkins forest. These are just some of the topics of his selected publications on copper deficiency when it wasn't known in infants in the early 60s. He was a staunch scientist in identifying, testing, and improving foods for feeding infants, that we call complementary foods today, but he was an early leader in helping to define what formulas should be, whether they are or not even today, what the requirements were for infants to grow normally, that they needed to have enough protein in their caloric mixture in order to promote adequate lean growth. He tested cereal products to see how they would best be used in combination with other foods to maximize nitrogen retention and promote lean body mass as part of linear growth. He was a leader in promoting and evaluating the digestibility of foods that could promote infant health and growth and so forth, especially foods that were available in his favorite country of Peru. And his studies stand today in terms of the discoveries that he made in terms of what is required for infants to grow well. We had the pleasure and honor of having a professorship named after George in 2005 through the grants and contributions of many people, the Mittendorf Foundation as well, but many individuals came forth to establish the professorship in his name, which I hold as a very humble honor to hold. This is just a few pictures of that inaugural event in 2005, and we have a copy of the image of the front cover of a book that Carol, George's daughter, wrote just this past year on happiness around the world. And Carol actually gave a special lectureship here in the fall on this book. And she'll be here a little bit later, but we're delighted to have her when she arrives, and Alec, that you're here to join us. We've had a few lectures before this now. It's become a tradition. Ken Brown spoke on food fortification to improve young children's nutrition in low-income countries, and was it HYPE or HOPE? And set the stage for what we consider to be provocative lectures. We don't like run-of-the-mill lectures in this lectureship. And Bill McLean, who was a longtime associate of George's, gave us a wonderful lecture on the use of and adaptation of small clinical studies to learn about the nutritional well-being of children from his work over 25 years in Peru. And then we had this mini symposium on the interactions of nutrition and infection that was the celebrated the 40th anniversary of the publication of a WHO monograph that was published by Scrimshaw, Taylor, and Gordon. Our own Carl Taylor, who was a major tree in another major tree in our Hopkins forest right up until his death last year. So that was a mini symposium. We had Charles Stevenson talk about effects of malnutrition on infection, Claudia Lanata about infection on nutritional status, and Bob Black from our Department of International Health to talk about the way forward. What was particularly a favorite of that event 2 years ago was that we had Nevin Scrimshaw and Carl Taylor bat ideas back and forth for about 45 minutes about their careers, what led them to talk about together earlier on and to get the nutrition and infection monograph put together. It was really quite a delight to have these two people speak. And everybody got plaques. Don't close your eyes, Andrew. You haven't seen this yet. And then last year we had Ricardo Wawi from the London School of Hygiene and Tropical Medicine, one of our favorite institutions here in Baltimore, here at Hopkins, talking on nutrition and linear growth and linking in George's legacy in terms of the things that he discovered, which leads us to today. It leads us to a talk about how to move from the bench to the clinic to the bush in terms of designing and evaluating nutrition interventions. And I brought my long boots here because I thought I was going to try to step over snakes and mud pits here, but it looks like they've cleaned up the place quite well. Andrew is a longtime colleague and friend. He directs the Medical Research Council's International Nutrition Group at the London School of Hygiene and Tropical Medicine. As Dean Clagg said, he was born in Africa, he's worked in Africa, he's dedicated his life to improving, through research, in a whole variety of ways, the nutritional well-being of children and mothers in Africa. He is the holder of many awards and is one of the most well-respected nutritional epidemiologists, nutritional immunologists working in our field today and over the past 20 years. And we're not the only ones that have recognized Andrew this week. He delivered the E.V. McCullum Lectureship at the Experimental Biology meetings just this week, just a couple of days ago in Washington, D.C., that was attended by thousands of people. So we invited you without knowing that you were going to be an E.V. McCullum laureate, Andrew, but because of the work that you've been doing over the years, we're very pleased to have you with us today, and please welcome Professor Andrew Prentice.
Wow. Thank you, Keith. Thank you, Dean. It's an enormous pleasure for me and honor for me to be here. I was saying to Al a few moments ago, this is my first visit to Hopkins. And he rightly said, how on earth have you managed to make any progress in life without having done that before? You know what an aura this institution has. You're quite intimidating to the rest of the world, even to us at the London School of Hygiene and Tropical Medicine, I would say. But it is a huge honor to be able to give this lecture this evening. It's a great pleasure to be involved with the Graham family by way of this. And I thank also the Middendorf Foundation. I thank in particular Keith for nominating me for this, and I have targeted this lecture really at the younger members of the audience. So when you get an opportunity to give a presentation such as this, I think it gives you a chance to step away from the normal sort of run-of-the-mill of presenting data, and we did this, we did that, these are the methods, these are the results, these are the interpretations. So I hope what I'm about to give will be of some interest. I hope it'll be of little controversy as well in relation to the theme of these lectures. The title is Bench to Bush in Designing Nutrition Interventions, Avoiding the Snakes and Climbing the Ladders. So of course one can go to Google these days and quickly find a few images. Now, you'll all be familiar with snakes and ladders. This one is a rather charming one, which has some helpful ladders and some rather cheerful snakes. I should say, when I was a kid, actually, I used to be obsessed by snakes and looking for them, particularly because in the back of the Uganda bookshop once, I found a very old copy of Pittman's Guide to the Snakes of Uganda. And I would read this avidly, and I was particularly interested in the bits that said as to how quickly people would die after they'd been bitten by a black mamba or whatever. Now this is an older one, which I found particularly interesting. You see that the bottom of each ladder is something that one has to do in order to move up the ladder. So the first one starts with penitence, and there's kindness and frugalness and so forth. And then you get eaten by the snake if you're responsible for cruelty, selfishness, pride, avarice, and so forth. I think what's notable about this is that at the beginning of one's career, if we use this as an allegory, I'm afraid, guys, there's very few ladders down the bottom there. You've really just got to go step by step. Perhaps just as interestingly, as you get up to the middle of your career, and maybe even towards the top, there's a heck of a lot of snakes that you might fall down. So beware of that. Now, I just want to very briefly sort of set the context, tell you a little bit about myself and what I try to do, so that you have a bit of a feel as to who I am. And then I'm going to get into the main theme of my presentation. So this is our little village in the Gambia, where I lived for many years and still visit at regular intervals. You can see here the village in the it's just south of the Sahara. You can see the great river Gambia in the background there. It's a very flat country, I suppose, over millennia, or over more than millennia, has been eked out and flattened by the river. It's a very poor community, but changing quite rapidly, particularly because of the remittance economy. And I think it's important for us to realize that these kind of environments are rapidly changing, and certainly the context of the work that I've been doing over the past almost 35 years there now, has changed, and it's important to remember that. When I was talking to the students earlier, I was saying that in a career of science, it's important to have fun, not to burn yourself out. So I'm not sure that I have a pointer, but you see the little bit, here we go. This bit there, that's my airstrip, and that's my hangar. I have a tiny little airplane that I have a lot of fun with when I'm out there. So it's a subsistence farming community. Very, very poor, lives on a frugal diet, as would be the same for the many communities that many of you work in. We're interested particularly in maternal and child health, and we take that from this pregnant lady with one of our mobile midwives. You can see the HemaQ and so forth, checking her out, and actually now at the moment giving her supplements as part of a large randomized trial, of which we've done many. We're extremely interested in the issue of birth as a moment in time. Of course, it's not just a moment in time, but a very important moment for the child, and the status of the child at this time is very reflective, of course, of their later progress through life and health. We've done a great deal of work on breastfeeding in the past. We're blessed by having a population that has fantastic breastfeeding rates, 100% breastfeeding. We never see an infant feeding bottle. They feed to probably the median, I haven't looked at this closely in recent years, but the median time of cessation of breastfeeding would probably be about 21 to 24 months. So very, very good breastfeeding. That's a wonderful advantage, of course, in terms of public health, but it's a slight disadvantage for us in terms of the research agenda, because we get no variance. We can't really look at women who are not feeding very well or who are not feeding at all. We, of course, spend many hours and lots of paperwork or computer forms now measuring children in all sorts of dimensions, as many of you in this room do also. It's been a very important part of our philosophy that this was set up by my mentor, who I must make a mention of, Roger Whitehead, who would have known and worked with George Graham to quite a considerable extent, I'm sure. It was part of his philosophy that we have no survey without service, no research without paying back to the community. So we have a very intensive pediatric clinical, well, not just pediatric, but a clinical service that we supply to the population free. We integrate that with the government services, and they probably get the best level of healthcare, I would say, for any rural community in Africa. And consequently, not surprisingly, they probably have the lowest mortality rates of any community in Africa, which again is a double-edged sword. Of course, we're very proud of that, but in terms of some of the research questions, that obviously makes a limitation. We don't study mortality at all, because thankfully there's little of it. And as I say, we integrate with the government health services in terms of vaccination programs and so forth. So I'm just trying to give you a little bit of color. We have a supplementary feeding program for the severely malnourished children, and this is just a picture, not in fact of our staff, but we ran a WHO training course recently. I love this picture because I know that this girl is now fine. She recovered fine, and she's a healthy young girl now. But I also love it because of the contrast it shows between this double burden of disease in Africa. We still have this so-called unfinished agenda of malnutrition and infections, and the coming agenda of the chronic diseases related to obesity and affluence. Now, we also have another particular attribute of these villages that we've worked in for so long. I should have said, incidentally, that the Medical Research Council has been working there since 1948. So 63 years now, or so. Is that my maths right? But, and it's a very special relationship between us and the surrounding community. And they're very cognizant of the fact that they are making a contribution to world health through their cooperation with all our studies. And my goodness, they're extremely patient in terms of the amount of work we do on this relatively small population. So one of the interesting features we have is a profound seasonality. There's an 8-month dry season where it can be guaranteed that it will not rain at all. And that's a picture of it about 4 months into the dry season. Towards the end of the dry season, even those trees lose all their leaves. So it's impossible to do anything. And that is transformed by the rains into a scene like this. Now, this all looks very good, but actually, paradoxically, it's the worst time of the year. It's wet and humid, so there's malaria. The mosquitoes can breed, of course, so it's the time of the greatest infections. But it's also the time which is the furthest from the previous harvest, and when people have to work really hard in the fields. And in terms of some of the work we've been doing on pregnancy and the nutrition during pregnancy, that's been a useful experiment of nature, because what happens is that the women lose weight during the hungry season, and they replenish this all during the harvest season. So this is fat acting as nature intended it, as a buffer against seasonal deprivation. And we've been able to use that. You can see that the variation is different in each year, depending on the quality of the crops in the previous year and things. But it's a very persistent and fairly reproducible phenomenon. And we use that. I'll just show you one example of how we use that in our research. It does, incidentally, impact on maternal weight gain in pregnancy, birth weight of the children, and so forth. So here's one fascinating finding that has generated a lot of research, a lot of our most recent research. We looked at the survival of people according simply to their day of birth. And we divided them into those born in the hungry season and those born in the harvest season, which we used as a proxy measure of nutritional exposure. And here's the fascinating outcome, which is that those born, we had a lot of early deaths. This is because this is data aggregated over from 1960 onwards. So, of course, our Kaplan-Meier survival plots, as I just told you, would be much flatter than that now. But this is aggregated data. And what it shows is that those people, there's surprisingly little difference in their mortality in early years. But then there's a latent effect which pulls through at about adolescence. And suddenly these survival plots disperse, and we see that there's a profoundly increased mortality in those people who were born in the hungry season. What were they dying from? Well, it wasn't any heart attacks or even road traffic accidents. Of course, they were dying from a mixture of things, but the majority of the deaths were either due to infections or to infection-related causes. So we hypothesized that events closely correlated with the season of birth have had a profound long-term impact on the development of the immune system. And we've been trying to follow up the biological mechanism of that ever since. We've now expanded our work from these core villages of Tenabar, Mandoa, Jali, and Canton Kunda, and we work in 35 villages. Unfortunately, we don't have nearly as big a population as Keith works on, and we're frequently envious of the sort of sample sizes that you work with. That does constrain the kinds of work we do, and to a certain extent has forced us towards the kind of more mechanistic research that we've tended to concentrate on. Just briefly now, we have within the team really 4 focus areas: nutritional modulation of immunity and infectious diseases, something we grandly call combating micronutrient deficiencies, which is a kind of catch-all bucket that allows us to do anything in micronutrients, calcium, vitamin D, and bone health, and nutritional genetics and environmental factors in disease. And what drives those is that they're all really issues of importance in emerging and developing countries. They're all related to maternal and child health. We try to concentrate on this knowledge discovery bit, and that's going to be the theme of my talk. But of course, ultimately, translation is the goal. So if we look at this as a sort of scientific spectrum, many of you here in Hopkins would be more towards this right-hand side, towards the applied and the policy ends. We tend to focus a little bit more to the left, to the more basic research. But our ultimate goal is a translational one. That's obviously where we want to get to. So with that as a little bit of a background of what I am, who we are, let me now dive into the real theme of this talk. So I'm going to start off with a very brief history of micronutrients. I'm going to use micronutrient research as a sort of exemplar of some of the points I want to make. I'm going to be very self-critical, and I'm going to be quite critical of our field of nutrition in general. So I hope I don't make too many enemies in this. Those of you who are not nutritionists, I hope I don't damage your impression of nutrition as a field. I'm doing this very openly because I think it's all too easy for all of us in whatever scientific domain we are to put up a whole series of slides and say how great we are. I think what sometimes is more difficult is for us to stand back from our discipline and look at the problems and see if we could do things better. And frequently when I'm sat on an aeroplane or whatever, you know, I anguish about how we're not doing our research well enough and we haven't achieved enough. So I guess this is a confessional here tonight, and I hope it might be useful. I particularly hope it might be useful for the younger members of faculty and students who can perhaps avoid making the mistakes that I've made. So no prizes for those of you who can guess your favorite nutrient amongst those, but prizes to anyone who can identify all of them. Very quick little bit of history. I guess the first empirical discoveries re micronutrients was that in Egypt it was discovered that feeding liver could cure night blindness, and that was apparently regularly used. Keith would know more, and Al would know more about this than I do. We move on to the famous stories of Lind and scurvy. This great collection of gentlemen, and I've frequently pointed out that if you want to do well in micronutrient research, you need to grow a mustache. So they worked on beriberi and scurvy again and so forth, and made some of the early seminal discoveries. Now, why do I put these guys up here in front of us? It's really to remind us that in the early days of micronutrient research, we concentrated on the associations between specific deficiency syndromes, specific micronutrients, and specific responses. And so, you know, I don't know what grade it would be in this country, but anyway, at a certain grade in high school, you'd all pretty much learn these associations. And that's important. These have been great successes. Numerous Nobel Prizes have been won as a result of these discoveries. These pure deficiency syndromes are now, thankfully, relatively rare, and certainly in extreme manifestations. And so if you look for graphics of these, you tend to come out with these old sepia tone or black and white graphics. And this part of my message is within that, because as a result of those becoming much rarer, we've now turned our attention to seeing if we can get greater gains from micronutrient interventions. We've had great successes, and I want to dwell on this slide because if I'm going to be a little bit destructive in the next coming slides, it's terribly important that I do emphasize the great triumphs that we've made, and particularly with someone like Al Summer in the audience here, it's extremely Well, it's a fantastic opportunity to say thank you for all you've achieved, and Keith also, and many of you in Hopkins. So just to put up a few of the examples, we've had some great science behind the relationship, the discovery, and now the implementation of the relationship between folic acid, pre- and periconceptual folic acid, and alleviation of neural tube defects. We've had the great story in terms of vitamin A, reduces child deaths 6 to 60 months without any shadow of a doubt, and the work that Bob Black and others here do in terms of zinc. These are the fantastic achievements. What I'm going to concentrate on now is I have a feeling that we maybe have hit some buffers and that we need to think afresh in order to unlock some of the barriers to further progress. We've moved to a bit of a search, and I suppose this isn't really a criticism of ourselves as scientists, maybe more of a criticism of some of the large foundations and NGOs. They really want us to come up with silver bullets. Can we use micronutrients to cure the world of everything? And the logic of this is very simple. Vitamins are very cheap to synthesize. Minerals are very cheap to purify. They're both, by definition, required only in micro amounts. And they're very easy to administer. Therefore, let's solve all the world's problems with these and all its associated ills. And we've got, I'm sure in this country, you've had issues that we've been struggling with in the UK about, micronutrient supplementation and reduction of crime, trials in prisons. I kid you not. Attention deficit disorder, everything you talk about, we're going to sort it out with multiple micronutrient supplements or even individual micronutrient supplements with mass administration campaigns. And of course, in order to generate the necessary funding for this, we've had a tendency to, and we're all guilty of this, but we hype up the problem. And we also hype up the effectiveness of our interventions. And here's the worst example I've ever seen of hyping up the problems. I'm sorry if I'm treading on any toes here. But, this poster here, 4.5 billion people, that's 3/4 of the world population, are suffering from anemia and iron deficiency. It's nonsense. And you can look at the history of how these numbers have been generated, and you can see floor after floor after floor, probably willfully committed in order to build up the case that we've got to do something about this problem. But personally, I think it's, at the end of the day, very damaging to our profession to be hyping these numbers up. We don't need to hype them up. There's plenty of problem without us exaggerating it like this. And then if our interventions fail, let's just try another nutrient. We have a tendency for this empirical approach. Or maybe we haven't given enough, so we've got to give some more of the same. Or maybe we've got to look at a different target group. Because, damn it, it's got to work. And we get disappointed and disillusioned if it doesn't work. There's been a vast amount of funding on these empirical trials, many excellent ones, and I must re-emphasize this, especially in this audience and in this place, that these been fantastic trials, awe-inspiring trials coming from Hopkins with great outcomes, but not always. Here, if you just do a search, and I did this very recently, of the trials registers, look at these numbers of trials that are currently underway or about to be underway. Now, if you look at the rationale for many of these, you'll find that they're pretty badly flawed. Let's now, I've talked about our successes, let's face up to a few of our failures and our disappointments. Now, I could do this, I'm just going to give you a few little examples in relation to global health and just picking on some of the issues close to my heart. But I could do this in terms of, diseases of affluence. I could do this in relation to the record of micronutrient interventions in cardiovascular disease, in cancer, in whatever. You'll all know, probably many of you better than I do, that we've had a large number of disappointments where the epidemiological association would suggest that intervention with nutrient A or B, or I shouldn't use those letters, H or J or K would be effective. But when large randomized trials are done and when meta-analyses of those are done, we find not only are they ineffective, but sometimes they are positively detrimental. So in our field of global health, we've had the successes of vitamin A in terms of child mortality, and of course in terms of dealing with the primary diseases and syndromes that are associated with deficiency. But we've had some worrying results as well. Walfie Fauci has shown, statistically significantly that there is an increase in the maternal-to-child transmission of HIV in mothers receiving vitamin A and beta-carotene in HIV-positive mothers. That's, of course, of great concern. They've been following that up and have started to indicate some of the pathways by which this might be occurring. There's increased detectable virus in breast milk in women who receive retinol and beta-carotene. And there's an increased rate of subclinical mastitis, which may then, by causing a breakdown of the mammary epithelial tissue, allow more virus to seep out into the breast milk. Now, nobody's sitting next to Keith, but could someone get ready to administer a large dose of anti-inflammatory vitamin A, please? Because I'm going to talk about Christine Benn and her theories that... So, as some of you will know, Peter Auby and Christine Benn have data, quasi-experimental, retrospective analytical data, suggesting that there may be a malign interaction between vitamin A administration early in life, especially coincident with killed vaccines, DTP, and that this may have a sex-specific effect in girls. Now, I know that some of you are extraordinarily skeptical about that. I'm on the fence, but the reason I raise it is that I think, there's no smoke without fire. I believe that this does require further investigation, and I do believe that it is biologically plausible. So it's another puzzle. The whole story about zinc, we can show that zinc is efficacious in terms of some endpoints, and if we extrapolate that up, multiplying the number of deaths that are related to those specific endpoints, we would anticipate that zinc would reduce all-cause mortality. And so these fantastic trials out of Hopkins were conducted. I was actually the trial auditor for the Zanzibar one, so I was able to see out firsthand how brilliantly that trial had been conducted. There's no doubt that it was done fantastically. But the result was a disappointment. In aggregate, there was no effect on mortality, either in the Nepalese or the Zanzibari trial. If we disaggregate that and look carefully, there's a suggestion that there may be a positive effect in boys over 12 months of age and so forth. But nonetheless, they're disappointments, and we need to try to understand why they were disappointing. And maybe the most infamous of all, again, was done by Sunil Sazawal and the team here, which was the outcome of the iron intervention in the Pemba trial, where the Data Safety Monitoring Board had to stop the trial early because there was a significant number of serious adverse outcomes, hospitalizations and deaths in the two arms that were receiving iron. And that, of course, has caused us to scratch our heads at all sorts of levels as to what was going on there. Just a couple of other examples about the disappointments we've had. Pregnancy. Meta-analysis of zinc interventions in pregnancy. You'll see many trials which will claim efficacy in one way or another, but if we do the meta-analyses, we find actually that there is a slight reduction in preterm births, but it's only just outside. The 95% confidence intervals are only just outside unity, and there are no other detectable benefits. Iron and folic acid, universally administered around the world, even in many poor populations in pregnancy. Of course, we have an effect on iron deficiency anemia and whether measured as anemia or iron deficiency anemia. We can reduce it, there's no doubt about that. We don't get rid of it all by any manner of means. But there are no other detectable benefits. And even the guys in WHO, JP, their conclusions at the end of this was that there's quite considerable numbers of side effects that need to be worried about, including hemoconcentration. So, we need to look into all of that in greater detail. We've recently had published the results of these 12, again, largely excellent trials of the UNIMAP multiple micronutrient supplementation in pregnancy. The net effect, or the aggregate effect on birth weight, is 22 grams. Do you know what that is in terms of an effect size? It's 0.04 of a standard deviation. So an extremely disappointing result. The relative risk for low birth weight, again, is reduced by about 10% or so, but only just outside the unity, the confidence intervals, and no other detectable effects. Then, of course, we've got this one from Betty Kirkwood's study, which failed to replicate Keith's NIPS trial, and Keith's own trial in Bangladesh has also failed to replicate the results. And I'll come back and I'll talk about our interpretation of these findings a little bit later. So we have, even without trying very hard, one can bring up a very large list of disappointments where, with all our best intentions, our interventions with micronutrients have not been effective. So how can we explain these disappointments? And more importantly, how can we try to do better in the future and break through the roadblocks? So I'm going to come up with now a long list of at least some of my conjectures as to where we may have made some errors and where I myself may have made errors. So I start off with an excess of optimism and zeal. Many of you will recognize there Linus Pauling, 2 Nobel Prizes, then went off the rails a little bit, I'm afraid, and was pilloried ultimately, actually post his death, I think, by the National Academy of Sciences and the Royal Society for his claims that high-dose vitamin C could cure the common cold and cancers. I've suffered this excess of zeal myself. We've done 2 trials of balanced protein energy supplementation in pregnancy in the Gambia many years ago. And we have shown in both of these trials, pleasingly, that we can have a significant effect on the proportion of low birth weight babies. And in the second of those trials, which was the larger one with a sample size big enough to test mortality effects, we showed that we could have a very significant effect on perinatal mortality. Now, why do I say this is an excess of zeal? Because this result has not been pushed through into public health intervention. Why has it not been pushed through? Basically because it's too expensive to try to supplement large populations with a comprehensive micronutrient simplified protein and energy supplement. So a success in scientific terms, but a failure in terms of translation as yet. Second point, we've often, I think, made faulty assumptions re causation. This is taught, of course, in every epidemiological course. Those associations don't necessarily prove causation. And we've already mentioned a few examples of where the misjudgment in relation to this has caused our trials to fail. Here's one example where actually causation was demonstrated. But it was demonstrated extremely carefully. So first of all, there was an observation notice that women who had neural tube defects had lower levels of folate in their blood. But they also had lower levels of various other micronutrients. And it took quite a deal of research and very well conducted multi-center trials in order to actually prove that folate was the key nutrient. And this, of course, has been pushed through into policy extremely well, including fortification here in the United States. And there you can see some of the trends in terms of neural tube defects. Sloppy hypotheses. I guess this is probably my favorite bugbear, or my least favorite bugbear. So it goes something like this. Children in Africa have many diseases and a high mortality. Children in Africa have poor diets. Children in Africa might therefore be deficient in vitamin X. In vitro studies show that vitamin X can affect immunity. Therefore, let's see if vitamin X saves lives. Now, obviously, I'm parodying all this, but I think, at times, and you can read the sort of introductions to some papers that we can all read, where it's not far, this parody is not far from the truth as to why they have done a certain trial. Now, of course, we would have to have, if we were doing drug or vaccine trials, we'd have to have a much greater discipline, and it would go something like this. We have a disease endpoint that we're interested in. We would usually have to understand the metabolic pathway. If we go to the FDA, not always now, they're getting looser on this, but in the past, certainly they would have wanted to know, what is your metabolic pathway? What is the mode of action of your compound? We would have then screened thousands of compounds. We would have done animal studies. We would have done the phase 1 trials, dose-ranging trials, which is a very important point, which we never do in nutrition. And then we would have ultimately got up to the larger phase 2, phase 3, and ultimately post-marketing trials. Now, what do we do in nutrition? Well, we don't need to do all this complicated, long-winded, and dirty stuff. We don't screen for compounds because we've already got them. We've got our favorite compound. Obviously, animal studies are done, but they don't tend to be done by the people who then go into the field and do the field trials. We pretty much dispense with phase 1 trials because we don't need to do them, but I think the important thing we have dispensed with are the dose-ranging trials. Metabolic pathways, who cares? Let's just see if it works. And then we go even one step worse than this. Very often we have our favorite nutrient, we do a trial, and we don't even know what disease or condition we want to cure, but let's do the trial and see if we can detect what it's dealt with. Do I sense that the audience is getting uncomfortable and hostile at this stage? We have the issue of single micronutrients versus multiple micronutrients versus food. So single micronutrient supplements, of course, may displace the homeostasis of other micronutrients. And there are complex interrelationships going on here. We have this Michael Golden's breakdown of these into type 1 and type 2 nutrient deficiencies would be just a start of looking at the complexity and trying to understand this. I think we're all well aware of that possibility, but often we still ignore it. And then, of course, the really important one is that the epidemiological associations that we initially find are very often found with quality of diet, and that does not necessarily equate to a micronutrient. Even if we find that biological levels in our children of micronutrients such and such are low, that can still be just a proxy marker of something else in the food that happens to be carried along with that micronutrient, which is actually the one that is effective in terms of health. And of course, in nutrition now, there's a great deal of interest in other bioactives that we wouldn't classically define as micronutrients, but may be having very important health effects. So we need to concentrate on food rather than just artificial derived nutrients. Populations might not be really deficient, or they might not be showing a functional defect. And I think all too often, and I'm as guilty as others, we've just completed a trial of long-chain PUFA supplementation in young children. We kind of dived in, PhD student had to get it done and things. We didn't do the proper baseline work. And when she analyzes all her plasma and breast milk samples at the end, we find these kids were never deficient in the first place, surprisingly, but we should have never done the trial. You know, we had not taken the time to do the background work carefully and really think through the need for intervention. And here's another little example of my own mea culpas. Here's some work I did many years ago. When we first started working there, children weren't growing well. We assumed that on these very poor diets, breast milk output would be compromised in these women. So we dived in and did a very comprehensive supplement, giving them a lot of energy and protein and micronutrients. It did absolutely nothing to their breast milk output. At the same time as doing the intervention, we were collecting output measurements from Cambridge, where our mother unit was. And when we looked at these, we found actually that not only were the Gambian women producing exactly the same amount of milk as the Cambridge women early in lactation, but they sustained their production much better than the Cambridge women later. So basically, there was no real defect in milk production, and that's a theme that we've shown time after time. And we shouldn't have done the supplementation trial in the first place. So again, faulty thinking in terms of the need to do the trial. This is a very important one. Our dose levels may be too high or too low. Are the RDAs accurate that we use as our references? That's reference dietary allowances? Do we need to give multiples of these or to replenish stores in kids who have got damaged guts and low stores? Or might we be overdosing? Should we really be performing dose-ranging studies? And I think very strongly that we should. Here's a listing, according to WHO, of the micronutrient requirements of a young child. Who in this audience knows where these numbers were derived from? Silence. Not surprisingly, don't feel bad. Who in this audience has ever done a study that has contributed to these numbers? Silence, because nobody has. These numbers basically are derived by considering a little child in the Gambia as a small version of a healthy grown-up American. And so we have very poor rationale. We haven't done the work, the background work, that would establish what are the nutrient requirements for these children in very different environments. And it may be that we're giving too much or too little. My favorite in this respect is iron. Iron is actually a very dangerous micronutrient. The Pemba trial gave us an exemplar of that. But we knew that way before the Pemba trial. Right back from the 1750s or so, physicians in Paris were warning against giving iron to their TB patients who would drop dead within a few days of receiving blood products. It's almost certainly the case that there is a very delicate optimum balance of iron status in relation to this constant battle between the human host and the pathogen. And this is quite a complicated graphic here, but basically if we have too little iron, we of course have immune deficiencies within the host, but the negative acute phase reaction is designed to take iron out of the systemic circulation to starve the bugs. And if we give iron back in, we're feeding the bugs, and there's going to be a fascinating paper in this respect come out in Nature Medicine in a couple of weeks, I hope. So look out for that in relation to iron and malaria. But it's likely that we've got to think very carefully about what is the optimal iron status, and that if we want to move this iron status to the right-hand side in order to improve the cognitive function of these kids, we've got to get rid of the infections before we can do that. I've put here inappropriate disease focus. I think, often we start our trials, we're a vitamin A man, or we're a zinc man, or we're, I'm an iron man, or whatever. Or we come at it, I'm a respiratory disease man, or I'm a diarrhea man. We tend to come at the trials like that. And we put them together. And this isn't necessarily appropriate. If we think about the infectious biology of what's happening to these kids, this is just a random set of kids, how they all line up in front of a camera. But if you could see that closely, you'll see they're all carrying signs of some quite serious infections. And the challenge to these kids is that they are always under an assault from a whole host of different potentially pathogenic microorganisms, be they bacteria, viruses, or protozoa. They have to be defending against all of these simultaneously. It's no good us coming along and tipping their immune response into a Th1 bias or so, because we may help them against one endpoint, but we lay them vulnerable to another endpoint. And frequently when we're doing our research, we're trying to test the effect of interventions on just a single or maybe a small combination of infections. I think we've had a failure to recognize complexity and context. And here's where this is an issue that Keith is very interested in and is frequently reminding us about in terms of interpretation of trials. So populations are not homogeneous. Of course they're not. Within populations, we have responders and non-responders, and we're starting to learn now about the genetic determinants of those. And soon we'll be able to understand that in much greater detail. Regions are not homogeneous, and exposures are not homogeneous, and those are all going to affect responses to our interventions. So here we have, in fact, Keith, thank you for you. Keith gave me a copy of this just yesterday, which has just come out. Here's a meta-analysis of vitamin A and childhood mortality. You can see that there is heterogeneity. Although we are persuaded by this kind of analysis that there's no doubt that it is beneficial, there are trials which are much less beneficial than others. And if we look at the issue in relation to neonatal vitamin A supplementation and mortality, we see not only is there heterogeneity, but there seem to be potentially opposite effects in Asia versus Africa. And we need to understand this context. Context is the word that Keith West uses. We need to understand this context and take it into account when we're interpreting the results of our trials and how we push that through into public health policy. Here's one which I'm going to return to just in a few moments towards the end of my lecture. We've got a disconnect between what we do on the bench and the bedside and the bush. And this is something that I spend quite a lot of my life trying to pull these things, these ends of the research spectrum together. And as I say, I'll make a few more words about that in a moment. I think our knowledge of mechanisms is far too weak. We've been looking on micronutrients for a century or so, but there's still so much we don't understand about them. Here's a lovely little boy, and isn't it wonderful to see how a little boy will look if you feed him properly and care for him, nurture him properly. So when he grows up, he's going to get his Land Rover or Range Rover, and occasionally it's going to go wrong. Now this reminds me of a little story of my mum when I was a kid used to take me to school in Uganda in a Fiat 500, and it frequently went wrong. So she'd be we even had traffic lights in Uganda in the 1960s. So she'd be at a traffic light and the damn thing would stall, and she would get out in her lovely, colonial frock and go around and open up the bonnet or trunk, whatever you call it here. What's the bit you call it front? And get out a brick that was stored under there and hit the carburettor. Put the brick back, shut the bonnet, get back in, car would start, and she'd be off. So how did she discover that she needed to do that and precisely where to hit? Did she go around the vehicle just hitting every little bit till she found the sweet spot? Of course, the answer was no. The answer was that my dad knew a lot about mechanics and knew that the carburettor needle was sticking occasionally, and that a good clunk with a brick would unstick it and all would be well. So the point of this little allegory is that we need to know how things are put together. We need to understand the manual of the human body much better than we do. And if we want it to run really sweetly, we have to have the measurements as to what the offset is on the timing chain such that ignition occurs at the moment of highest compression and so forth. So we've really still got to put together the manual of the human body. Now, this is a very daunting task. Here's just a fairly basic schematic of the complexities that we've got to try and cope with. And I want you to just do a mind game of trying to understand this as a multidimensional box where any one interaction between all these things is a cell, and we need to fill that cell with knowledge. So I've just listed a few of the micronutrients there. Some of our favorite ones in relation to immune function. I've listed just a very tiny number of the variables that we might have to study in order to understand immune function. These, of course, are impacted on by these multiple vaccines, ever-growing number of vaccines that we throw at children. There's going to be age dependency effects, critical windows. They're going to be modulated by the host and the pathogen genome. And all of those ultimately are going to impact on disease outcomes. And we need to understand this. And if we looked at that multidimensional box, we would find that in most places those cells were completely empty. For instance, we knew nothing about the effect of PUFA on mast cells in relation to, I don't know, I'm making it up, BCG in the gut or polio in the gut and the response to immunization. So most of them are empty. Some of them have a few bits of information in them, and very often those few bits of information are conflicting. So how do we put all this together and do the job better than we've been doing in the past? Audience quiz time. Vitamin A saves lives in children 6 to 60 months. I hope no one would argue with that, especially with Al in the audience. What diseases does it protect against? We have some quite good information, but we could certainly do with a great deal more, and we're not very secure on that. What is, or I should write, are the immunological mechanisms of this? Actually, we haven't a clue as yet. What's the optimal timing of dosing? What's the optimal dose level? We throw in a huge amount of vitamin A. We do it because it's convenient to do so in a public health setting where we don't see these kids very often, and the amount we give is calculated in terms of replenishing hepatic stores of the micronutrient. What is the metabolic fate of the dose? Do we know how much is converted to retinoic acid over what scale? Of course we don't. We haven't done the pharmacodynamics of that. And how do all of these vary by the environment? So, I don't think any of you, had I allowed you to answer, not many of you would have been able to give a really comprehensive answer to any of these questions because we don't have that information. So how are we going to do this? Well, there's two ends of the spectrum. Either we can take the really reductionist approach, which we've tended to do in the past, and we tease apart and we study each tiny little bit of this problem. We can't afford to do that over all of this. We'll have to be very, very selective if we take just the reductionist approach. This, to me, is a very exciting paper that, again, just came out about 10 days ago, which really is starting to inform us. I'll just throw this up in front of you. I'm not going to go through. I don't have time. It's not the place to go through the details of this paper. But it is suddenly opening up to us, I think, a greater depth of understanding in relation to the mechanisms by which retinol, through its transformation to retinoic acid by dendritic cells and macrophages in the gut and associated lymphoid tissues, is having a very subtle effect on immune responses in terms of the balance of inflammatory and anti-inflammatory. So at certain times it is assisting the gut to be tolerogenic, to have an appropriately anti-inflammatory role, but it needs to be able to switch very quickly to the inflammatory role in response to certain infections. And what this paper shows us is that the amount of vitamin A and the timing of that, this is just really a summary of what I've just said, but the amount that we give may be critical. It's very sensitive. This paper, albeit in mouse models, shows that it's very sensitive to dose. It's very sensitive to timing. We need to understand the pharmacodynamics of that conversion from vitamin A to retinoic acid. Timing might be ultra-critical in relation to vaccine administration. And excitingly, I think they provide us some new proxy markers as to what we can go down after in terms of the T regulatory cells and the various inflammatory markers on ex vivo stimulation that we could use to do these kind of studies that we need. So that's the one approach. The opposite end of the spectrum is the big picture approach. And I think the challenge for us in global health and global nutrition it is listed here, really. How do we most intelligently harness all these wonderful new technologies to our ends? How do we get these incredibly clever people to answer the questions in relation to public health? And I've just had a very exciting half hour in Keith's company where he was showing me some of the fantastic work that you're doing here in terms of proteomics and trying to understand some of the relationships with micronutrients, developing better biomarkers for status and for functional status. So you're well on. I'm preaching to the converted, at least in relation to some of you here. But we've got these great omic sciences. I think of special interest is this issue of the microbiome. 9/10 of the cells of our body are in our gut. They're non-human cells. We have a very characteristic microbiome. We each carry our own. To some extent we inherit it, but it develops very early in life. It is bound to be having an enormously powerful effect on our health, particularly in relation to our nutritional health. We have to understand this. We've got fantastic new imaging capabilities. We can do massive microarray studies. We've got next generation cell analyses. Mark Davis in Stanford can measure a zillion things in a single cell with mass spectrometry. we're very familiar now with the sort of gene manipulation studies, knockouts, knock-ins, conditional knockouts, conditional knock-ins, which are teaching us a lot about the function. Huge amount of GWAS. You know, if you're in the GWAS field, you can get a Nature paper out pretty much every week at the moment. But their day at the end, they're having their day at the moment, but the end will come, don't worry. And we're going to have to do the mechanistic studies that come out of that. When we find these strange new associations that we'd never thought about before, we've got to then understand the biology behind that. And then the whole issue of systems biology, a very easy phrase to say, very difficult to do, and in silico modeling. So there are huge opportunities. And what I was saying to some of you at lunchtime today is, you know, be brave, grasp these, and try and pull these techniques towards your own ends as you work in the global health field. Here's just a couple of examples. Jeff Gordon, I think, has been, you know, really seduced towards global health with the aid of a large amount of Gates Foundation money, it has to be said. But he's really intrigued by this whole issue and working closely with Mark Manari and others in Malawi and trying to understand the relationship between the microbiome and malnutrition. Here's some work we're doing in the Gambia. I'm not going to dwell on this or even try to explain it, but this is just a graphic to show you the kind of stuff that, of course, people are doing in terms of these heat mapping, looking at responses, looking quite agnostically at the responses to interventions, be they a vaccine in this case or administration of vitamin A or whatever. You can look agnostically, you can look at this pathway analysis, principal component analysis and so forth, all very complicated stuff, but ultimately is going to inform us of a large number of new mechanisms of disease that we've never thought about before, and that we will then be able to use to fit together and understand the pathways within nutrition and global health much better. So, I'm going to sum up now just with 4 very simple recommendations. There could be many, many more, but these are just some that I think are the easiest to start grappling with. I think we need to be more disciplined with our initial hypotheses in relation to some of these issues. We need a greater rigor of thought, and again, I'm speaking to the younger ones in the audience here, not to follow my errors. And as part of that, I think we need some tougher funding decisions so that we prioritize our investment. Money is short at the moment. We've got to use it wisely. Reduce waste, and ultimately, and this is really important for nutrition, we've got to enhance our credibility because it is suffering amongst our colleagues in other sciences at times. I think we need to reject this issue of oversimplification. Biology is very complex and very subtle, and we need to, instead of running away from this complexity, we must embrace it and say it is important for us to understand this complexity in order to understand the big picture. And we've then got to try and boil it down. And I think this will enlighten our understanding and may help to clarify the muddy waters. My third point is where possible, trials should include mechanistic research. This is a very personal bias of mine, but I don't see why it's not possible. Actually, a randomized controlled trial is one of the best ways of testing not only the possible public health importance of an intervention, but also of testing the biology. We've got a system, we think it may be affected by a nutrient. Tweak the system, give the nutrient, see what happens. We can do that, and we should be doing that mechanistically, even in these very large trials. And trialists should partner, I think, with the lab rats. And that's going to help to promote basic principles better, and also to help us to interpret the sometimes disappointing or aberrant results that we get from our randomized controlled trials. And lastly, and perhaps most importantly, is to exploit the new technologies through collaborations. Nutrition has to take part in big science. It's by definition, nutrition is one of the most complex disciplines. We can't do it alone. We've got to get these big, clever guys on board with us and remind ourselves that they need us every bit as much as we need them. You know, they're not going to continue to get funding if they just hide away in their labs. And so we need to help direct their attention towards global health problems. And I think the Bill and Melinda Gates Foundation are doing a tremendous job in this respect in terms of their grand challenges. They've really pulled a lot of clever people towards the issues of global health. And ultimately, this is going to open up new frontiers of knowledge and help us to build those new health interventions. So with those few quite simplistic thoughts as to how we can do things better, I'd like to thank the many people, this is just a tiny number, of my friends and collaborators in the Gambia and throughout the world with which we do our work. It's a little reminder that you should have fun during science, and I say thank you very much for your attention, and thank you very much indeed for the honor you've given me of this marvelous award. Thank you.
Thank you, Andrew. We have time for some questions, a few questions. So we would like to hear them.
So Andrew, so thank you. That was a great talk, and as you hoped, it's provocative. And so I wanted to speak first because I don't do nutrition.
Right.
Okay. I don't have a horse, you know, in this race. But I do care about clinical trials a lot, and you know, my experience, you know, starting in clinical medicine, cardiovascular disease, hypertension, and so on, is that the biological mechanism that if you, for whatever finding you find in a clinical trial, if you can't come up with a biological medicine or a mechanism, you just didn't go to medical school. I mean, I've seen so many. I've seen people stand on their heads with good data to explain an unexpected finding, and then when you do a bigger trial or you do the meta-analysis, you find out it was just a sample size. You know, aspirin and cardiovascular disease didn't work in women in the first few trials because the event rate was low, but you know, had a different cyclooxygenase, and it was based on good data. So I guess I'm just pushing back. Maybe I have too much of the classic epidemiologist in me on understanding the mechanism, because human, you know, we're such complex systems that it's really hard to understand mechanisms, you know, because there are so many pathways being affected. And is it important for policy to understand mechanisms? So I guess I'm asking you, why so much emphasis on understanding mechanisms?
Okay, well, thank you for that. I mean, I certainly, you know, we need you to push back. Let me try and give you one shortish response. There's an interesting presentation at EB just recently by Kurt Long about some of the work he's been doing on vitamin A and responses to different diarrhea, to diarrhea in Peru. And ultimately, you know, in aggregate, there was absolutely zero effect. But when he starts to tease it apart by the different organisms, albeit with rather small sample sizes, but it does look as if the response of E-tech may be quite different to S-tech and other organisms. So, you know, and he started to, again, maybe his hypothetical mechanisms are going to prove to be wrong, but I think at least we need to try and explore to understand this issue about vitamin A and respiratory disease. You know, what is going on there? We've got some strange findings, which at least if we understood the mechanisms better, we would be able to, I think, inform ourselves of more targeted trials. Because one of the things the traps we're also falling into, I think, is the assumption that we need to find something so simple that we have to be able to apply it uniformly to everybody in the world, at all age groups, for instance. Now, clearly that is not the case. I mean, we would never do that in clinical medicine. And I think understanding the mechanisms is going to be important in terms of teasing apart which groups are going to benefit most. So that's just one small example. I mean, you know, hopefully later we could explore that, because I think it is an intriguing argument. And with your pushback, I have to accept that very often we don't have the funds to do the mechanistic research. You know, there's only so much research money out there, and we wouldn't have the funds to do everything. So I'm not in any way arguing to stop all clinical trials whilst we do the mechanistic research. I hope you noticed that what I was arguing for was actually building the mechanisms on the back of more clinical trials so that we get a better understanding. I mean, no way arguing one or the other. It's more a partnership between the two. And I think many of our large trials have not done enough, even basic testing that would help us to interpret the results.
So this really was a very thoughtful presentation, Andrew. We appreciate the effort that you've put into this. It seems that given that these fronts need to go forward, and actually everybody needs a job to do. If you work on rats, you don't really usually work on people, and vice versa. So we all have our job to do across this cell to society continuum. And it seems that where the responsibility and demand on our assets are more than ever before is for basic scientists to understand the human environment and complexity and the research that goes on there, and the epidemiologist and trialist to continue a lifelong effort to understand the cellular mechanisms so that the trialists can be informed better about what to test. And the basic scientist, as I think has been the case over the past 20 years in some of the micronutrient work, the basic scientist is better able to test the mechanisms that are most likely to mimic the human condition. And we reach convergence there and move forward with our successes, with our failures, with our disappointments. So it's more of a comment that I think what I've pulled out of your talk is a very constructive set of guidelines beyond the four that you have enumerated, that we have a job all before us, and it's no more demanding than ever than amongst our young scientists, because they have the neurons, first of all, to absorb all this, understandable, and the science of mechanisms on which we understand mechanisms has never been more revealing. So I wish I had a darn question.
Thank you, Keith. No, but that is a very useful. I mean, you've summarized more eloquently than what I would have hoped to do. I guess the message is for the young ones amongst the audience here, especially in nutrition, to really be brave and embrace those very complex sciences. We're going to need to do that, I think.
Andrew, thank you. One of the things I'm a little perplexed by is some of the things that you called failures were based on meta-analyses,
which I then went on to undo.
Which essentially takes everything out there, irrespective of the heterogeneity. And then you eloquently talked about how complex things are and how context may, at various levels, may be important. And I find that a bit of a disconnect.
Definitely.
And I don't think the failures perhaps are failures that are based necessarily on these meta-analyses, but perhaps that as a way of trying to make things very simple may really miss some of the richness of the studies and in the various contexts in which they're done. I guess the second question I had was the pharmacologic model that you had presented. For me, it's a bit of a far reach to think about a nutritional deficiency in the same way, or sort of using the disease model, and I've struggled with that because the deficiency of you have a very specific disease agent which may have a very concrete biological and pathological pathway. I find it difficult to think of a paradigm that where nutrition will sort of so easily fit that paradigm, where you move from that disease condition to some of understanding the metabolic pathway to the phase 1 and phase 2 and phase 3 trials. And I was just wondering if there are other paradigms that might be more relevant relevant to the
Okay.
study of nutrition?
Well, I mean, I think there are examples. I mean, the folic acid and neural tube defect is one, but I'm immediately going to argue against my own case because, that was empiricism at its best in a way, and we still don't understand what the exact mechanism. I mean, we are starting to understand in relation to epigenetic marking and so forth. Maybe we have just reached that tip point of understanding what the mechanism is in terms of that. But that would be one example, and I think there are many. Perhaps you notice, though, that in that lineage, I really emphasize the dose ranging studies several times. That's the issue that I think we need to deal with most in nutrition. I'm not necessarily arguing that we have to go back and put together all those pieces of the jigsaw, but the dose ranging thing, I think, is something I'm thinking about currently in terms of our work in the Gambia, really, quite carefully, because we just read these things off the packet of the WHO leaflet, really, bung it in, and give it to the kids. We have no idea whether it's the right amount. And there are studies that occasionally, show that we're giving too much, not only in terms of iron, but some of the other micronutrients. So I think that. Your first question was also, absolutely to the point. It was more a criticism, which I accept, of the way I presented it than my thought process. I'm not a meta-analysis man myself. I, hate it. We've got this new discipline in England now where pretty much every PhD student is forced to do at least a comprehensive systematic review, and preferably meta-analysis as chapter 1 of their thesis. I hate it. You throw the baby out with the bathwater so often. But nonetheless, let's take those UNIMAP studies of the effect of pregnancy. We may not like the meta-analysis, but if we go back and ask, well, what describes the difference between those different trials? We can't explain it because we don't understand the basic biology. So, I think that is sort of an argument in both directions.
Coming to the point you were telling to the young scientists to go for the basic mechanism, as the main problem is the funding. Like, for example, for the zinc study, zinc and diarrhea. Like, when I was thinking of doing a study with individual diarrheal organism and how it is affecting with the zinc, I had to face the questions.
You have to get what, sorry?
I have to face the questions.
Yes.
That what you will do new. It's already there, that
Right.
zinc is affecting diarrhea. But we need to know the mechanism for individual bacteria, like how it is affecting. But it's very difficult to get funding.
Okay. I think there are ways of doing it. It probably is very difficult for a young person to get funding, and I sympathize greatly. But I guess the line I might take there would be this. First of all, we have fantastic new diagnostics for identifying the organisms in a stool sample. So one route is to collaborate with people who have the tests. They've spent a long time working on the diagnostics, and they need the applications. That was the point I was making in terms of the technologists need us as much as we need them. And then, people who are deeply embedded in the biology of zinc metabolism, often they're struggling to get a grant, because when they put in their grants, the question is, well, what's the application of this? So I think one of the tricks is to marry together the applications which we have. And actually, I see that as the biggest job I have as a leader of science in the Gambia here. My job is to go around the world like this, talking to people who have clever techniques and saying, would you mind coming and doing that? And very often they'll do it for free, because they're delighted to have the opportunity to try their GWIZ technique on a population in Africa. So maybe that's a route you can try and take.
I think we're going to need to. Is there another question? One more question.
Thank you very much for a very thoughtful lecture today, and I'm very much impressed. So I'd like to ask one small question. That is, how do you see the traditional food or traditional meals that finding one nutrient may do good about something like that? This is an area of the research, but I thought in a way, taking one example of like Chinese food. Chinese traditional medicine sees drugs and foods share the same root, and they don't try to get into each ingredient or element to do better or not. It's almost a complex compound
True.
that will do better. There may be a lot of synergism and antagonism. But getting to the issue of the trials, that is the current traditional foods may be the product of long-term 4,000 years trial upon humans, and we are having some final set menu to be good for people. So how do you see the traditional food available over the world to see a kind of outcome of the trials?
Well, a very, very good question. I didn't really dwell very long on that bit where I was making the distinction between micronutrients and foods. One could talk about that for many hours, and I certainly sympathize with what I understand to be the motivation behind your question. I think we might be able to start to understand this in various ways, again using the new technologies. This understanding of the microbiome and how that is affected by foods and food constituents I think is going to be fascinating. And also our genetic background, because our genes will really give us, if we're intelligent enough to read it, give us quite a good readout as to how we have adapted to these various different diets and various different ecological niches. And we're starting to understand, some of those. I mean, we have some very simple but fascinating examples, like the issue with the lactase persistence gene, and that has developed, we're told, at least 7 times independently throughout the world. So, showing how important that is as an adaptation. But that's a rather extreme example. Steve Zeisel gave a very nice presentation at EB about genes that limit the efficiency of nutrient conversion. And I think once we start to get into those sorts of things, we'll be able to build a more complex picture of this whole issue. But we need to avoid the simplicity of just considering micronutrients. You're quite right.
Thank you, Andrew. You have informed, you have provoked, as we were expecting, and you have stimulated, as we were also anticipating. So thank you very much for this wonderful talk. We have just 2 more minutes of our program. We would like to welcome Carol Graham. Carol arrived through the traffic, and it's really wonderful to have Carol and Alec both here today with us. Also, this has been also a wonderful lecture as part of the 50th anniversary celebration of the Department of International Health. So it's a birthday year, and we're trying to bring lots of speakers into the department to give great talks, and this is going to be a tough one to top for the next one to come down the pike. We do have a plaque, and we would like to have Dean Clagg give this to you. So please, Mike and Andrew, if you would come up. This is become a tradition.
My person. Oh, there.
This is a plaque that is made in a village not far from our study site in northern Bangladesh, and has become an icon of this lectureship. Would you like to read it, Dean?
Sure. So it's the 5th George C. Graham Lectureship, Bench to Bush in Nutrition Intervention. So that's nice to have the and then our logo, and then Andrew Prentice, BSc, PhD, London School of Hygiene and Tropical Medicine, for excellence in improving child nutrition, April 14th, 2011, the Johns Hopkins University Bloomberg School of Public Health. So congratulations. Are you willing to skip that to you? Can you tell
As I've said already, I am truly honored. This is a most fantastic honor to have from Hopkins in particular. Thank you.